All right, so it looks like we're live on YouTube. So just to get back on the things, by the way, good evening, everyone who are participating here today on the day 2 of Electric Vehicle Powertrain Bootcamp. Uh, and part of today's bootcamp, we will be discussing about powertrain sizing using Microsoft Excel. All right, so it looks like we're live on it. Yeah, so we will be discussing the details to do a component sizing, at least the motor for today's discussion. So this session will be delivered by Mr. Krishna, so he's our senior simulation engineer at Decibels Lab. So to practice in this session, as we have already told you, you need a file to basically practice. So if it is there on your laptop, and you also need an Excel software to practice in the computer. So I believe you are all ready with that. And for rest of you, enjoy the session. And Krishna, the overview for the session.
Thank you, sir. Yeah. So, like with the continuation of yesterday's, like you guys have like just had an introduction to the EV system. So, like you went through the systems, like the components of the EV, like maybe like motor controller, like battery, like all the stuff, right? So, like we should be knowing like how to size the components, like when it comes to, if I, as I mentioned, like powertrain sizing, right? So it is nothing but a source, like plus your drivetrain system. So where the drivetrain, it will involve like uh, the wheels, transmission systems, all the stuff. Okay, uh, right. So like considering that, like how to size like your source, like the power you had to supply to your vehicle, right? So like what should be your like motor size, like maybe in terms of like torque or like speed, right? And again in terms of battery, like what should be the energy and the capacity, like that we'll be getting to know from this particular webinar. Okay, yeah. So here, like first, like we'll go through like uh, what we are going to like the content that is agenda of this today's like session. Okay, so we will be going like we'll be going to approach a wheel to well analysis. Let me show you here, like wheel to well. So well is nothing but your like source side. Okay, where wheel like which will be your like is nothing but strong, like exposing your like vehicle's energy to the environment. Okay, that is like what we define in general. Okay, so uh, whenever like what vehicle is trying to move, there is always a resistance uh, which is received from the environment, you can say. So considering all those like things, we have to go for sizing the components. Okay, so first, like we will decide like what is required at the wheel side. So to decide at the wheel side, like we should be knowing what is required at the wheel side, like maybe in terms of torque or the speed or like force, anything that we have to like calculate. Okay, so first that we'll be dealing with here, like calculating all the resistive forces, and we'll go through the some basic definition of it and equations which we are using. And later, like we'll move into the driveline dynamics, where like it will be involving your transmission system, motor system, and the battery system. Okay, so as per our like session, like we'll be dealing up to the motor system. Okay, yeah. So it's nothing but your backward facing approach. So as I mentioned here, like wheel to well analysis, this will be like your vehicle body, like where we will be only involving our like longitudinal motion, that is front and the back motion of your vehicle, like reverse direction. Okay, so here like whatever the resistive forces you will be like estimating at this particular part, that is at the vehicle body. And later we'll be involving our transmission system, where the gear ratio is like it's already sized, and the motor system on the later stages. So first, like we'll go through vehicle body side. Okay. Yeah. So here, like as I mentioned, on the vehicle body side, like I mentioned about like vehicle longitudinal vehicle dynamics. So basically, like as you see in this figure, like the vehicle moving in this direction, like don't worry about the length and all the stuff. Okay, just see the forces. Like one is like F arrow, and like R XF, that is nothing related to the rolling, and then there is some gradient. Okay, yeah. So like all these forces are acting against the vehicle motion. Okay, so whatever the forces acting on the vehicle, right, are like just balancing the forces using this has the equation, that is F is equal to m into a, that is Newton's law. Okay, so from there, like we are deriving it here. So like all the forces are on the one side, like these have been like detailed here, like what exactly they represents. Okay, so these like represents your like total tractive force, or like R related to your like Rx related to your rolling resistance. F arrow is nothing but aerodynamics, and F grade is gradient force. So like here as we moving in the backward facing approach of calculation, right? So we need to calculate like total tractive force. Okay, so this we have to calculate. Like if you consider Ft, that is total tractive force, equal to F arrow plus rolling force plus grade plus your acceleration. Okay, so these are resistive forces, and this is like used for traction. Like I will explain it later. Like okay, yeah. So first, like we'll go through the resistive forces which is acting over the vehicle. Okay, yeah, we'll get into like what exactly the resistive forces and how to estimate like calculate the resistive forces. So like this is just like to represent the contribution of all your forces. Okay, so if you see this like particular pie chart, like I just mentioned, uh, aerodynamic force is contributing somewhat here, like tire rolling is contributing in somewhat some percentage, and rest others losses. Okay, where the gradient is not included here. Like you might be like thinking that okay, aerodynamic force is somewhat like contributing in higher percentage compared to the others. So like what are the factors is affecting so that it is contributing in such a like high number, like with respect to all the forces, like we'll look into it. Okay, yeah. So like rolling resistance, like we'll start with the like rolling resistance, like has one of our resistive forces. So like first we'll get to know like parameters affecting your rolling resistance. Okay, so here like we know like the basic thing, like has the wheeling comes in contact with your road surface, like there is, because of contact patch, there is some resistance. Okay, so what are the parameters affecting your rolling resistance? Or like as I'm seeing this particular figure, like I have already mentioned some like points, the tire pressure, the weight, uh, okay, and like the design of your like wheel, like maybe the tire width size. Okay. uh, the contact, like obviously like the contact patch is derived from your width of your tire. Okay. And the material and the surface. Okay. Like we'll look into it each one. So like as we talk about like surface, like contact patch, right? So like if you consider like wheels, like will be of like two different width sizes. Okay. Has higher the width size of your wheel, uh, the area at which comes in contact while the vehicle making a rotation, sorry, while the wheel is making rotation, right? uh, this particular some area at this area. Okay. So it will be like higher compared to your lower width uh, wheel. So it means like higher the width size of your wheel, there will be higher area of contact patch. So again, it's one of the parameter. Okay. And the weight, like obviously like affects on the pressure. Okay. And the pressure, if you see like effect of your pressure with respect to the velocity, like okay, like according to your car speed, like on the y-axis it has mentioned with the coefficient of rolling resistance, on the like of the different tire pressures. Okay. Yeah. So here like this is like one of the parameters. uh, One more is like CRR value, like that is we defined with respect to the road surface. Okay. So if you are like trying to drive a vehicle on the different surfaces, like maybe on the concrete road, asphalt road, or like mud road, or like terrains. Okay. So it'll be defined with a different CRR value. Okay. Like it will just show like how best the rolling resistance it is trying to give. Okay. What exactly these coefficient value defines, right? Yeah. And the temperature, like at the higher temperatures, like your wheel will be like losing its energy. Okay. The tire material. Okay, not wheel. Yeah. And if you talk about the different tires on the rolling resistance, like the different materials, if you consider like there will be some different rolling resistance at the different pressures of the different tire material. Okay. So like usually like each time as the wheel makes one rotation, there is always some losses. Like we call it as like hysteresis losses. Like if I define in terms of like uh, graph, so as the wheel make a rotation, has some part, the top part of the wheel comes in contact with the road. Okay. On the surface. Okay. This particular part. So at that position, like it is nothing but you are loading. Okay. And when like it continues its rotation, like at the later stages, like that particular part is unloaded. So again it will comes back. So if you see this particular graph, right, like loaded at one magnitude and coming at in the other magnitude, like there is some difference, right? So it is like each time it is getting there is some loss in energy, that we call it as a hysteresis losses. You can like just look into in the deeper like how it's going to act. Okay. Yeah. Yeah. So these are some like parameters. Okay. uh, to calculate like rolling resistance, like we have like plenty of equations like which will be defined based on curve fitting methods, or like considering many of the parameters. But in generic, like we'll be using this equation. Okay, so if like again, as we defined, the rolling distance value will be like again uh, considering the velocity of your vehicle, the pressure of your tire, and again it depends on different category of the vehicles, maybe like light vehicles or like heavy vehicles or like kind of. Okay, so in general, like for our calculation, like we'll be considering this equation. Okay, yeah. So like I will define these terms like once we enter into the calculation part. For now you can just take this equation. Yeah, so next, like we'll define like aerodynamic force. Like in simple, like uh, as your vehicle moves, right, like the air is offering some resistance, like the molecules which comes in contact with your surface of your vehicle, it's offering some resistance to your vehicle motion. Okay, so like if you consider what are the parameters like involved, like as we in the earlier slides we saw the pie chart where the aerodynamic force was contributing in a larger value, okay, in a percentage wise. So you can see like most of the equation components, like they are in directly proportional, like all the components. Okay, like uh, this is the equation, like uh, aerodynamic force equal to zero 0.5 rho a cd and v square. So rho is nothing but your air density, a is like area, cd is coefficient of drag, okay, and v is velocity, like it is squared. Okay, it means like has let me clear, like all the components are like directly proportional. Any one of the components increases, obviously it's going to be affected. Okay, the aerodynamic force. uh, for our calculation, like we'll be using this particular equation as a generic. There are some alternative equations, like again it depends, like uh, the wind, like in the extreme wind blow conditions, like if it is against our vehicle motion, then we have to consider wind blow. Okay, then we have to add it to our existing vehicle speed. Like if we are moving along the like blow of your wind, like along the direction of your wind, so like we have to subtract it, so it will be like yeah, somewhat like supporting. Okay, yeah. So these are some alternative equations. Like if you are like precise data, we can go for these uh, calculations also. Okay, yeah. But for our calculation, like we'll be using this equation. Just make a note of it. So as we were talking about like uh, dependencies, uh, one like as we mentioned, drag coefficient. So the same thing how it defines, like with the different like size and the shape of your vehicle will be having the different coefficient values. So if you see many of your automotive structures, they are lean with streamlined body or like half streamlined body. So considering that, they have like very less drag coefficient. Okay, so yeah, this is where also like we have to consider. That's why like vehicle dynamics comes into very play. uh, like always people trying to like go for lesser cd value, that is coefficient of drag. Okay, and even the surface of your vehicle, like it's also matter. Like as smooth as your like vehicle surface, like there will be like lesser drag coefficient, because if it is like somewhat like not much clear on the surface, right, so these will again affect the air motion, sorry, the air resistance. So yeah, that's also matters how we uh, design the structure. Okay, And like one more parameter like velocity. Okay, so let's say like as the velocity of your vehicle increases, the aerodynamic force increases, because it is like force directly proportional to v square. Okay, yeah. So again, the air density. So again, like air density depends on your temperature. If you see the different parts of our country itself, like if you go to some north, complete north side, like you like there will be like cold, like obviously there will be like higher air density as the temperature decreases. And like at the higher temperatures there will be like less temperature, sorry, less air density. Okay, so like these are like one of the parameters. Yeah. um Let me just give me a second here. Oh, will there be any changes in the okay, like with respect to the query questions, or like we'll take it at the end. Okay, yeah. Does the material used the body affect it? I don't know much about like material. I don't think it is. uh, the next question like about aero force, if the force is very surface is very smooth, or like yeah, that was I was mentioning, like if the surface is smooth, or like it's again affects your like aerodynamic force like in the positive way. Okay, like yeah, your drag coefficient will be very less. It is good if the surface is too much of smooth, or like we call it as like friction drag. uh, we'll avoiding like if the too much of your smoothness of your structure of your vehicle, right, like the surface, so we will completely avoid the friction drag. Okay, yeah, just check out in the Google like what is the friction drag, you will get to know. Yeah, so like to calculate the aerodynamic forces, like as I mentioned, um, or like we have to consider this particular equation. Yeah, okay. So now like we'll move into the gradient. Okay, so as we define like gradient force, let me go to here. Yeah, so if you consider a flat road, like whenever like you have a condition of uphill, like or the downhill, like you're going to face with the gradient force. Okay, so like one of your like force vector will be acting at angle, that we call it as like gradient, that is nothing but your theta. Okay, the inclination angle. So here this gradient force is defined with this particular equation, or like plus or minus GVW um, star sine pi, or like inclination angle. Okay, so like the purpose of mentioning plus or minus, whether your vehicle is moving uphill condition or like downhill condition. Okay, yeah. So now like as I was explaining about the forces, right, the resistive forces, one was like aerodynamic force, or like rolling and gradient. Okay, and now like I'm including the acceleration force, where not at all it is a resistance, but the purpose of adding uh, along with the resistive forces and getting to know what the total tractive force. Okay, because let me take an example here. Okay, this is somewhat like a block kind of. Okay, so this is what a some surface. Yeah, so there is some force acting, that is some F arrow something, and the rolling. Okay, a rolling force is also acting. Let's consider like it is a flat condition, there is no gradient force. So here like let's say like aerodynamics somewhat like 35 and rolling somewhat like 15 Newton. Okay, these are like some random values. Okay, so the total against force like for its movement, the block movement is somewhat like 50 Newton. So now you are applying a force here to move this block in this particular direction, as I mentioned with purple color. Okay, yeah. So if I apply like 49, the block won't move, like still like 1 Newton has to be like supplied. Okay, so as I apply 1 more Newton, that is like make it 50, again it won't move. Like now the balance of the force has been done. Now like it means if you consider only resistive forces for your sizing of your motor kind of thing, at the end you will just balance like the resistive forces at your vehicle side. So again, like if you apply, let's say like if you're applying 51 Newton, then like this block will start moving in this direction at some speed and make it 60 Newton, or like again it will start moving with some greater speed. Okay, so whatever like overcoming of your resistive forces and also like required, and at the different desired speed, what is the required force? That is nothing but your acceleration force. So that to get to know about that, we are adding this particular force also. Yeah, so here like as I mentioned, first like we'll be adding like resistive forces and the acceleration force to get uh, like about the total reactive force. Okay, once we got to know like total reactive force, we'll be like estimating our wheel torque. Okay, so this is should be radius. Okay, yeah, so wheel torque, which is in Newton meter, so force will be in Newton, and like radius of your wheel will be in meter. So yeah, you're nothing but you're like calculating wheel torque, and using this equation like we'll be calculating wheel speed. So like these are like some basic engineering equations like which you study in basics of your engineering. Okay, yeah. um, Conversion of like speed into the RPM thing. Just try to note down these equations like we'll be like using in the calculation part, all these equations. Okay, yeah, let me skip these things. Now like for this transmission modeling, like as you calculate the wheel side, that is wheel speed and the wheel torque, that completes your vehicle body side. Then like you will be moving into the transmission side. So you will be the output of your transmission, that is you will be estimating motor speed and the motor torque. So for that you will be using these equations, motor speed and the motor torque. Okay, that is like gear ratio is already like has been sized. Okay, like again the sizing of the gear ratio is again a different entity. Yeah, so with this equation like we'll be calculating motor speed and the torque. So once we get to know motor torque and the motor speed with the help of like basic equation, like we will be calculating motor power, that is 2 pi nt upon 60. Here 2 pi nt upon 60. T is nothing but your motor torque. Okay, it should be m. Yeah, and n should be like motor speed. So with this you will be calculating motor output power. Okay, here if it is your motor, right, so this will be like your motor output power. We are going in the reverse direction. So first we will estimate motor output power. So like we will be including our some losses here, like we are adding the losses in terms of efficiency, and then we will getting to know like what is the input power. Okay, so for that like we are going to divide the motor power output power by motor efficiency, like we'll get to know motor input power. And like again there is a component comes between motor and the battery, that is nothing but motor controller. Okay, so as you calculate the motor input power, uh, there is like again a component called motor controller. Like there is like the power like will be coming from the battery. Okay, if the battery supplies like 100 watt, the output of your motor controller might be like 90 watt. So again there will be some losses in the motor controller, like as it is of power electronic component. Okay, so if you consider that like some efficiency, motor controller efficiency, then like we'll get to know like battery supply power. Okay, so like just try to like note down these equations, or like we'll start with the calculations. Yeah, so like what I will do, I'll just go to the Excel sheet. Just give me a second. Yeah, so I hope like you have this drive cycle. Just let me know in the chat box if you have this particular drive cycle. Which contains time versus like velocity, velocity upon time. Sorry. Yeah. Okay. Yeah. So let me plot this one. So here, like I will be like using NEDC drive cycle, that is New European drive cycle. Okay. So on the y-axis side, it is nothing but a velocity, and on the x-axis, it is nothing but a time. So here, like if I try to explain like drive cycle, right? Like uh, it will be like containing the varying speeds, or like if I want to try it in like simple definition, so like a different speeds at the different time. Okay, where it involves like all kind of uh, traffic behaviors. Okay, like maybe like irrespective of any road conditions. Okay, like maybe it has some potholes, or like traffics, or like pedestrians walking on the road. Okay, so like including all the traffics. So a randomly driven like vehicle with collecting some data along with it. Okay, so we can define it as like drive cycle. Okay, so the drive cycle behavior will be like at will be different at the different areas. So if you are considering the highway, so you always try to maintain like more than 60, or like for longer time of your run, right? So if you come to the city side, like high traffics, so hardly like we'll be touching the top speed, like not top speed, like some 60s or 50s, or like most of the time like we'll be lying at this area, like 20 to 30 kind of thing. Okay, so it depends, right? Yeah. So again, like under the drive cycle sections, like with the which behaves at the different, like which tells the different characteristics of your like driving behavior, will be characterized into different sector, that is like urban drive cycle, like rural, uh, highway drive cycles kind of. Okay, yeah. So this is NEDC drive cycle, like a standard which represents your like European conditions. So we'll be like calculating all our like motor requirements, uh, okay, for this particular drive cycle. So what I will do, I'll go to the like first I will copy these two, control C, go to next sheet, I'll just paste it here. Okay, now like I'm trying to put some input parameters here. So like we with a known vehicle, like I'm trying to put some like vehicle to derive into the motor structures, like we have to input the values like of the vehicle side, like which is defines its structure of it. Okay, like maybe you are talking about like driver mass or like vehicle mass, kind of like radius of a wheel, all the stuff. So first like we'll mention vehicle mass 111, driver mass 81, or like 80 something you can take, or like standard we can consider it as 80, or 70 you can consider, it depends. And CRR, that is coefficient of rolling resistance. So I'll just consider of like roads like 0.015, wheel radius 0.1524. For here calculation, like we don't have grade angle, so we'll consider grade angle as 0. Okay, and then like air density, we'll just name it as like rho, 1.22. On your side, like just try to write the units of it. Okay, frontal area 0.875, gear ratio 7.8, transmission efficiency, transmission efficiency. When you're trying to like transfer your power or to one system to other, there is always a loss. Motor efficiency 0.9 something. Motor controller, okay, efficiency 0.85. Coefficient of drag, I'll just write it CD 0.22. Or like G, that is acceleration due to gravity, or like it is 3.142, that is pi value. Now I'll define like GVM and GVW. So GVM is nothing but your gross vehicle mass. Okay. So let's say like your which considers like, let's say GVM equal to vehicle mass plus driver mass. So if you add vehicle mass plus driver mass, you will get like gross vehicle mass. So what I am going to do, just bring a equal sign, add vehicle mass plus driver mass, say enter. And if you multiply G, you will get in newtons, that is nothing but a gross vehicle weight. So what I'm going to do, gross vehicle mass multiply with G, say enter. Okay. Yeah. So like these are some like input parameters. I think I have some messed up. Yeah. Sorry. It should be not 3.24. G is acceleration due to gravity, right? 9.18. Nine point eight nine. It just give me a second. Yeah. Okay. Okay. Now it's correct. Like G is, let me write it in here itself. Otherwise, I'll get confused. Acceleration due to gravity. Okay. Yeah. So, like as we consider, like these are input parameters. Now, like we'll start like calculating all the resistive forces and like whatever the requirement at the wheel side. So first, like uh, velocity is in like kilometer per hour. So we'll convert into meter per second. Like most of our parameters are in meters. Okay. The unit has to be like in the same to make a apple to apple comparison. Okay. Yeah. So I'll just write, well, here to convert velocity into meter per second, I'll just write equal sign, select, multiply with 1000 divide by 3600, say enter. So just drag it to end of your cycle. At that point, if you double click, it will also like bring that particular value. Okay. If you just double click over here, I don't know, like it didn't work on my PC here. Okay. Yeah. With the velocity, or like first I will estimate wheel speed. Okay. So wheel speed, like equation is V multiplied to 60 divided by 2 pi, that is 3.142, multiplied with RW, that is nothing but a uh, wheel radius. So here, like this is a constant value, right? Like it means um, it remains same for all the like parameters of your velocity, all the values of your velocity, right? So uh, when you are like trying to calculate for all your velocity values, like it has to be constantly multiplied. So if you drag it from here, so it will also try to go on taking the different values which is mentioned here, and later null has a value. So it has to be constantly supplied to this equation to multiply. For that, I need to make like bring a dollar symbol to it. Okay. Now say enter. Yeah. Say enter. Now if I double click, I will like this particular value will be like constantly multiplied. If you see here, you can see if I take it here, like this particular value is constantly multiplied. Okay. Yeah. Now like wheel speed has been calculated. Now to we have to calculate wheel torque. So to know about the wheel torque, we should be requiring total tractive force. For to calculate total tractive force, we have to calculate uh, vehicle resistive forces. So first, like I'll start with aero force. F aero. Okay. So we know the equation, that is 0.5 multiplied with rho. Sorry, rho is nothing but your air density. You have to go on adding dollar symbol. Okay. Again multiply, um, bring a multiplication sign, and rho CD. Okay, dollar symbol, and multiply with frontal area, dollar symbol. Okay, and multiply with like one is radius and v square. Okay, so here you can like bring a shortcut, or like you can just multiply with g2 and g2, that is it will make it v square. Okay. Yeah, now say enter. Just drag it to the end if that doesn't work. Okay. And now like I'm going to calculate rolling force. So this will be like constant value. So like acceleration due to, sorry, GVW. So bring a dollar symbol multiplied with like GVW and multiplied with wheel radius. Okay, say enter. Sorry, it should be multiplied with CR. Sorry. Yeah, just to bring just a second, bring a multiplication sign. Yeah. So this will be like constant value. Okay. And gradient, like we won't be considering because like gradient angle is 0. There is no inclination. So all the values will be like 0. So like we'll just neglect this particular part. Okay. Now like we'll calculate here acceleration force, ACC F. So like before, like acceleration force, like F is equal to m into a. So acceleration and multiplying with the mass, that is GVM. Okay, gross vehicle mass. So acceleration, like you will be deriving it from the wheel speed, that is like by applying like basic, um, getting to know like V2 minus V1, um, T2 divided by T2 minus T1, right? Using these equations, like we can calculate acceleration. Yeah, and further multiply with the GVM. So we'll end up with the acceleration force. So here what I will do, like equal to, bring a bracket, V3, that is G4 minus G2, close bracket, multiply with GVM, divide by 2, say enter. Okay, just drag, or like if that doesn't work. Okay, what mistake I have made, right? So for the GVM, it has to be constantly multiplied. So for that, I need to bring dollar symbol. Yeah, now like we are getting some data here. So now, like we can go for estimating total tractive force. So total tractive force, just go on adding all the forces, F arrow plus F roll plus acceleration, say enter. So we don't have gradient, so we just neglected that particular part. So once you get to know about total tractive force, you can go for calculating wheel torque, wheel speed. It was already has been like calculated here. Okay, so now we'll be like calculating about the wheel torque. So wheel torque, like force into meter, that is like Newton into meter, that is total for tractive force multiplied with wheel radius, bringing out the dollar symbol here, center. Yeah, and like as you get to know about the wheel torque, like we can go for estimating motor torque and the motor speed. Okay, so here motor torque. Yeah, so motor torque, like as we went through the equations, like wheel torque divided by gear ratio multiplied with transmission efficiency. So what we are going to do here, bring a bracket over here, select wheel torque divided by, okay, bring a bracket, select efficiency, gear ratio and efficiency, gear ratio, bring a dollar symbol to both parameter, multiplication sign, and efficiency. Okay, close bracket, say enter. Yeah. Um, okay. Yeah. I think I need to bring one more close bracket. Center. Yeah. Yeah. So, like now we'll calculate motor speed. So just need to multiply with the gear ratio. Uh, Wheel speed multiplied with gear ratio. Okay. Say enter. Yeah. So once we get to know motor speed and the motor torque, we can calculate motor power. That is motor output power. I'll just write out dash P. Okay. So 2 pi, that is 3.142, 2 pi nt, that is motor speed and torque multiplied with speed divided by 60. Say enter. Yeah. Which will be in watts. Okay. And then like motor input power. So I just need to take out like motor output power divided by motor efficiency. Bring out the dollar symbol. Say enter. Yeah. And to calculate the battery power, that is supply, equal to motor power divided by motor controller efficiency. Say enter. Okay. Yeah. So this comes like an end to your like calculation part. So we'll just like go through overview of your results and then we can like wind up. Yeah. So I'll just like consider motor torque as we are like focusing on only on the motor side. I'll bring out some graphs here. Motor speed, motor torque, and the motor power. Yeah. So like the trend of the motor output power and the motor input and power will remain same. The trend of the graph. Okay. Only the efficiency like has been like included here. Okay. Yeah. Now like if we talk about like motor torque, right? Like when it's come into the when it comes into the sizing and selecting like let's say like peak torque or like continuous or the like rated torques or the peak speeds, or sorry, max speeds, continuous speed, and same with respect to the motor power, uh, max power and continuous power. So if you talk about like motor torque, right? So here like if you consider this is a like continuous torque, okay, you can just neglect these spikes. Again, it depends on different drive cycles. Okay. So where your most of your like spikes lying, so like continuously you can consider. Here you can consider like 4 to 5 has your range for your continuous stock or like your rated. Okay. Just neglect this negative part. It will be like defining about your region. Okay. Yeah. So if you want to consider the peak values, right, like we have to like go for inputting, uh, like here whatever the velocity we have considered, this is some like a varying velocity, or like maybe of cities, or like some like less traffic city, or like or highway kind of. For to consider peak torques, motor torque, you have to go for like performance curves. That is nothing but your accelerations. Okay. Yeah. So from acceleration curves, where the curves will be in this pattern, or like from zero, or like end up with like top speed something like, let's say like 15 seconds. It has taken like 100. I'm just taking random example. Okay. So this will be like continuously like driven like to the top speed. So what we are making use of these curves kind of for to estimate the peak torques. Okay. So as the speed increases, like the torque goes on decreasing. Like that is a basic criteria, like uh, a basic rule. You can say like motor characteristics curve, somewhat like in this pattern. That's why like at high speeds, you are going to like see the lower torques. And like this is about like motor torque, continuous torque, and like nominal torque or the peak torques. And the speed from these you can like see uh, the max, it's somewhat like 10,000 rpm, where like continuously like somewhat 5,000 to 6,000. Again the base speed is going to be different, it depends. Okay. Yeah. So usually like the continuous data, like while when we are mentioning to the suppliers, like we'll be mentioning it with some value, and uh, the instant time for it will be mentioning it as a indefinitely. For peak talks, for the peak values, or like let's say like the motor should be have the capability of like achieving peak talks for 10 seconds kind of thing, or like 15 seconds kind of. Okay. So in that way, like it will be defined to the suppliers, again with the same parameter at the motor side. Okay. And the same like goes for the motor power. So peak powers and like continuous powers, somewhat like 2000 watt, and the peak is about like 3000 watt. Okay. So again to go for like peak motor power, like you have to consider the performance curves. Okay. Yeah. So like motor, or like once we like consider of like deriving it to some data, right, like maybe uh, sizing our final value, we had to go for like lot of iterations with a lot of drive cycles. Then only you can get to know like about nominal values. Okay. Even with less iteration of your acceleration of that is fine, like based on your segment, maybe it is for like commercial application or race application, depends. So like if it is even for commercial, like to define our nominal requirement, I had to go for like a lot of drive cycles, I had to do the lot of iterations, then only like we'll end up with some final value. Okay. Yeah. I'll just stop sharing the screen. Yeah. If you have any doubts, or like just put it in the chat box, or just give me a second. or like we'll end up the sessions. Like it's almost like 1 hour of the webinar. Those who like left behind in terms of calculation, like you will get the recorded video even in the YouTube and to your dashboard. You can refer it. Even you can get to that particular file. Um, okay. For the gear ratio, like whatever the vehicle parameters I have used, right? It is application for Ether 450. So I taken that 7.8 from there itself, from the sheet, like from their websites itself, kind of. Okay. Yeah. The sizing of 7.8, like how they come into conclusion that we should be going for 7.8. Again, like that area is completely different. Like a lot of algorithms will come, like one of them like linear optimization algorithm, search optimization, like it's a different area. Okay. Yeah. uh, yeah, that will be like how they'll come into first without like in that algorithm, like first without gear ratio they will be like estimating the motor side requirements. Let's say like considering as a hub without gear system. Once we get to know the data on the motor side, then again they will go for reverse estimations, uh, like for the gears in that approach. Okay. Yeah. For the Indian drive cycle, there is a standard for in the ARI where it is get tested. That is IDC. You can just check in the ARI websites. We'll get in detail. Okay. Yeah. So just let us know, like if you have any questions, or like we can wind up the sessions. Thank you.
Guys, if you have any questions, you can leave it in the chat box. Okay, thank you, fine. Thank you everyone for joining in, and thank you Krishna for taking the session.
Yeah.
Yes,
Thank
you
you.
can leave the session. Thank you, Krishna. Tomorrow will be the day 3rd, so we'll be giving the certification. So please do join us tomorrow as well. Yeah. Okay. Once again, thank you everyone for joining in, and thank you Krishna for hosting the session.